Hey folks, we got another kind of problem here. This is Dalton's law over water. Let me start this problem off by explaining what it is that we're looking here. If I am doing a reaction, okay, so here's the reaction that's taking place right here. Kind of like the reaction we did in class where we made the balloon. Okay, so let's say that I changed that apparatus ever so slightly, and I had a piece of tubing which went into a pool of water. Okay, and I did that zinc and hydrochloric acid reaction. I made hydrogen gas. Okay, if I made that hydrogen gas go up through this tube and then back down the tube into water and then bubble up through the water, and I collected that gas over water, that's the kind of problem I'm referring to here. Okay, you may be thinking, well, when do they ever do that? You'd be surprised. Okay, sometimes it really is important to do reactions like that. Now, one thing that you have to take into consideration is that now all of the gas which is inside of this, okay, is not all hydrogen gas. Okay, you've also got water vapor, which is going to be caused from the water evaporating. So what you have to do then is you have to subtract out the vapor pressure. So let's go ahead and look at a problem. I've got 50 milliliters of hydrogen collected over water and has a pressure of 850 torr at 27 degrees Celsius. What would be the volume of the dry gas at STP? Okay, well, right now, if this is being collected over water, we're going to call that a wet gas because it's the gas, it's the hydrogen gas, and it's water vapor. Okay, so let's write down our givens. Okay, my V1 is 50 milliliters. My P1 is 850 torr. And my T1 is 27 degrees Celsius. Okay. I want to find the volume of the dry gas. So that's unknown at STP. Okay. And so I know that standard pressure is 760 torr. And I know the standard temperature is 0 degrees Celsius. Now, as I mentioned before, this 850 torr right here, this pressure of my wet gas, that's the pressure of the hydrogen, and it's also the pressure of the water. So what we need to do is we need to subtract out the vapor pressure. How do I know what the vapor pressure is? Well, let's look at this right here, 27 degrees Celsius. This is a very important number, okay? What we want to do now is we want to flip to the last page of our notes, okay, to this vapor pressure chart in torrs. Okay, now I think there's another, oh, no, it's just all in torrs, okay? So what I need to do now is I need to say, okay, 27 degrees, where is that? 27 degrees. Oh, here it is right here, okay? And so what I know now is that at 27 degrees, the vapor pressure of water is 26.7 torr, okay? So let's go back up. Let's go back up to our problem, okay? Here's my 850 torr. Of this 850 torr, I've already forgotten the value now, 26.7, I think. 26.7. Of that 850 torr, 26.7 of that is water vapor. So I'm going to subtract 850 minus 26.7 to find out what my value of my dry pressure is. So 850 minus 26.7 is 823.3. So 823.3 torr is my pressure of just my hydrogen. That's what I've got to focus on for this problem. Okay, now I know that I also need to convert my temperatures to Celsius, so we'll do that as we are dealing with our problem. So I've got V1, P1, T1, V2, P2, T2. Okay, so I know that this is going to be a combined gas law situation, so we're going to do P1, V1 over T1 equals P2, V2 over T2. And so now let's plug in what we can. I know that my original pressure, oh, I come right back to my givens here, 850 minus this. So my pressure that I'm dealing with is 823.3. My volume that I'm dealing with is 50. My temperature is 27 plus 273, okay, because it's Kelvin. So that's going to be 300 on the nose. Equals, I changed it to STP. Okay, so I want to find out the new V2, so that's just V2. My pressure is 760, and my temperature is 0 degrees Celsius, which is just 273 degrees Kelvin. 273 Kelvin. Okay. So now we'll cross multiply. So I'm going to do 300 times V2 times 760 equals 823.3 times 50 times 273. In order to get V2 by itself, I'm going to divide both sides by 300 times 760. Cancel, cancel. And so I see that V2 equals 823.3 times 50 times 273. Enter. Divided by, open parentheses, 300 times 760, close parentheses, enter. 49.3 milliliters is my new volume. Was it milliliters? Yeah, milliliters. Okay, 49.3 milliliters is what the volume of the dry gas would be at STP. Okay, now this, as you probably noticed, this is just like a regular old combined gas law problem. The only difference is that you have to subtract out the water vapor pressure if it tells you that it's over water. Okay, if it tells you that it's over water, you have to subtract out the vapor pressure. That's all you have to do. If you see the term over water or dry gas, something like that, in the same problem, you know that you're going to be doing an over water problem, and you'll have to subtract out the vapor pressure. Okay, what's the name of the law? Dalton's law. Dalton's law over water. That's it, my friends. We'll practice more in class.